This is GATE 2014 Set 3 EC question number 6. A series RC circuit is connected to a DC voltage source at time t equal to 0. The relation between the voltage source and the resistance and the capacitance and the current IT is given below. Which one of the following represent the current IT? So you can refer to NPTEL lecture number 14, capacitor relationship of voltage and current and initial condition of the NPTEL course network analysis by Professor Taposh Kumar Bhattacharya, Department of Electrical Engineering, IIT Kharagpur, and the YouTube link is given here. This full data that will be needed to solve this question is that the voltage across the capacitor cannot change instantaneously. So the voltage at just before the initial condition and just after the initial condition and the voltage at equal to 0 are all same. So Vc cannot change instantaneously. Also, using final value theorem, we can write the voltage across a capacitor can be written as voltage across the capacitor at t equal to infinity plus Vc0 minus Vc infinity into e to the power minus t by tau, where tau equal to R equivalent of the circuit into C. So this is the theorem, and this is also valid for current. So IC of t equal to IC of infinity plus IC of 0 minus IC of infinity into e to the power minus t by tau. Tau is same. So this is the formula you will be need. Coming to the solution, it is given that a DC voltage source and there is the resistance R and C, capacitance like this. So now at t equal to 0 it is closed. So at t equal to 0 minus, the circuit was like this, open circuited, and this was the R and C and this was the DC source. So the voltage across the capacitor at t equal to 0 minus was 0 since the source was not connected. So at t equal to 0, Vc0 equal to Vc0 minus equal to 0. Voltage across the capacitor cannot change instantaneously. Now at t equal to 0 plus, Vc0 plus equal to Vc0 equal to Vc0 minus equal to 0. At t equal to infinity, that is at steady state, the circuit will be like this, Vs, and this will be connected, this will be R and this will be C. Now at steady state, C behaves as open circuit and all the charge will come here and the voltage developed will be same as Vs, as this will be open circuited. So Vc at infinity equal to Vs. So at 0 plus, the circuit will be connected like this, and at t equal to 0 plus, since the initial voltage across the capacitor is 0, it can be shorted. Now the current across the capacitor IC0 plus equal to Vs, this Vs divided by R, and IC at steady state is 0, capacitor becomes open circuit. I hope the concept is clear, because after just connecting the switch at t equal to 0, the voltage across the capacitor will be same as it was in t equal to 0 minus, which was 0. So voltage across the capacitor was 0, so it can be replaced by a model by a short circuit like this, and the current across the capacitor at just connecting the switch, after just connecting the switch, is Vs by R, and at steady state the capacitor becomes open circuited, so the current flowing into it is 0. So IC infinity is 0. Now applying final value theorem, IC0 plus is found out to be Vs by R, IC infinity is found out to be 0. The theorem states that the IC of t equal to IC of infinity plus IC of 0 minus IC of infinity whole into e to the power minus t by tau. Then ic of t can be written as ic of infinity, which is 0, plus ic of 0, which is vs by r, minus ic of infinity, which is 0, e to the power minus t by tau. Now tau here is rc, right? So we can write ic of t equal to vs by r e to the power minus t by tau, where tau is rc, so minus t by rc. So this is a exponentially decaying function like this. Ic of t versus t is like at t equal to 0 it was vs by r, and then as time passes at steady state capacitor becomes short circuited, and then as time passes capacitor becomes open circuited and the current decreases, and at t equal to infinity, that is a steady state, it becomes absolutely 0. So the correct representation of the I of t function is like this. So A is the correct option.